Hello and welcome to Radicals 3.2 Rational Exponents Part 2. Okay, so we're going to continue from where we left off the last time, and we're going to do problems 4, 5, and 6. And there's going to be a little less problems today on this lesson, but it's probably going to get a little more complicated. So hopefully you guys got the first part pretty well, and you understand that part pretty thoroughly, because if you do, it's going to make this part a little easier. But if you come into this lesson without knowing that first part really well, this second part is going to get even more crazy. Okay, so yeah, hopefully you're coming in here prepared. All right, so let's continue with this problem and this first problem, and let's just get going. So this first one says we're going to simplify this radical. Yeah, we're going to just simplify it. And we're going to just basically look for 4 things that match, because that's what kind of radical it is. It's a 4th root radical. And if we see 4 things that match, then we're going to circle them. Okay, so let's start breaking things into tiny pieces. So we got a 4th root radical. Let's make a big, gigantic radical symbol, because I got to write a whole lot of stuff in there. So the 9 I'm going to rewrite as 3 times 3. Then I'm going to write 6 x's, 2, 3, 4, 5, 6. And I'm going to write 4 y's. And I'm going to get my red pen and I'm going to circle things that match. So I'm not going to circle any 3's because I don't see 4 3's. But I will circle 4 x's and I will circle 4 y's. Okay? And that tells me that x and y go outside. The 4th root radical is still in play. But here's where we're going to do something a little different. I mean, well, we did it the last lesson also, but we didn't do it many times before this. And in all the other times that we did radicals before, we didn't do this before. So this is going to get a little getting used to. So we're not going to times these guys together and make 9. We're going to write this as 3 squared and x squared. Okay, normally we don't ever write 3 squared. We just go ahead and write 9 right away. Okay, so this is going to take a little getting used to. And the reason why we want to do this is because we can simplify this radical, meaning we're going to grab all my tiny numbers. So we're going to grab the 4, we're going to grab the 2, we're going to grab the 2, and we're going to say, of these 3 numbers, do they all divide by something in common? Because if they do, then we need to do it. We're required to do it. Okay, so 4, 2, and 2. Do they all divide by a common number? And you're going to hopefully say, yes, they do. They all divide by 2. So if you divide all those tiny numbers by 2, here's what you get. So you got your radical symbol. And instead of writing a 4 in there, I'm going to write a 2 now, because I divided 4 by 2 and I got 2. And instead of writing a 2 connected to the 3, I'm going to turn him into a 1 because I divided him by 2. And the x as well. I'm going to divide his 2 by 2 and I'm going to get a 1. Okay. So then this is where the students usually ask, do I need to leave the 1's there? The 1 next to the 3 and the 1 next to the x. No, you don't. You don't have to leave them there. Yeah, the only reason why I leave them there is because it shows me that I did the process called simplifying. And it showed me how I got the 4 to become a 2, how the 2 became a 1, and how the other 2 became a 1. So I can kind of visually see the pattern. Okay, but when you write your final answer, you don't got to write the 1's there if you don't want to. Okay, but that problem is done. All right, so let's look at letter B. So same exact concept. We got a 6th root radical, and we have a ton of stuff that we got to write inside the 6th root radical, because I got to find 6 things that match. So break apart the 8, and that is 2 times 2 times 2. Break apart the x's. Wow, that's a lot of x's. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And 9 y's. Wow, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so let's circle things that match. So I'm looking for 6 things that match. So I got 6 x's right there, so I'll circle that. I got another 6 x's, so I'll circle that. And I got 6 y's, so I'll circle that. And I don't have any more y's. Okay, so let's see who's going outside. Well, x and x are going to go outside to make x squared. A y is also going to go on the outside. This is a 6th root radical. And I'm not going to write this as 2 times 2 times 2, which is 8. I'm going to write it as 2 to the 3rd. and y to the third. Okay, and then I'm going to reduce my radical. So I'm going to see if all my tiny numbers can divide by something in common. So I got a 6, I got a 3, and I got a 3. Do they all divide by something in common? And the response is yes. Okay, and here's where kids make a mistake. Okay, when you reduce your radical, you don't reduce the x's and the y's that are outside already. You don't touch them. You just reduce the numbers that are associated with the radical. So the 6 and the 3 and the 3. You just reduce them. Don't touch the numbers on the outside. Okay, so x squared y stays the same. And divide by 3, so the 6 becomes a 2. The 2 to the third becomes 2 to the first, and the y to the third becomes y to the first as well. And you're done. Okay, so it's going to take a little getting used to this new simplifying process, but after you do enough problems, you'll get used to it. Hard part is when you don't see this for a long time, and then I throw a quiz at you, then you're going to be like, whoa, what do I do again? Yeah, you're going to get all lost. Okay? All right, so let's look at this next one. So once again, it's a 6th root radical. And let's break apart all our numbers into tiny pieces. So now we got 64 inside the radical. So 64 is known as how many 2's? I believe that's 6 2's. And let's just check. 2 times 2 is 4, then 8, 16, 32, 64. Yep, 6 2's. And then 4 x's, and 8 y's. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, I'm going to get my red pen, and I'm going to circle 6 things that match. So I got 6 2's, and I got 6 y's, and I'm not going to touch the x's because I only have 4. I need 6 to circle them. Okay, so who's going outside? So 2 and a y are going to go on the outside. It's still a 6th root radical. And then I got x to the 4th, y squared. Okay, so let's reduce my radical. So 6, 4, and 2. What can they all divide by? I think they can all divide by 2. So the 2y stays the same. And I'm going to divide all my numbers inside the radical by 2. So this is going to become a 3. The x is going to become a squared. And the y is going to become power of 1. Okay? So hopefully these 3 problems that you just saw right back to back to back kind of gave you a pattern, a sense of understanding as far as what you see for a pattern. Okay? All right. Number 5. Okay, so now we're gonna combine x's that are within a fraction, and they both have their strange powers that are fractions. And yeah, like I said, yeah, today's lesson is going to be a little bit more complicated. It's going to look complicated, and it's going to somewhat be complicated as well, unless you get the hang of it. Okay, so in this problem, you got your x's that are connected with division, and when your x's are connected with division, basically what you got to do is you got to subtract your powers. Okay, when x's were connected with multiplication, you added powers. Okay, so it's a difference in I guess operation that's going to cause you to do different things when you connect the powers. So multiplying x's, add the powers. Divide x's, subtract the powers. Okay, so since there's an x on the top and there's an x on the bottom, we're going to subtract the powers. So you're basically going to get x to the 5/3 minus 1/4 power. Okay, and we're subtracting the powers because my x's are being divided. Okay, so make sure you understand that connection. Dividing x's, yeah, means you subtract the powers. All right, and since you're going to subtract these fractions, you got to make sure they have the same denominator. So I think they're going to match at 12. So multiply this first fraction by 4/4. Multiply the second fraction by 3/3. And that's going to cause them to have the same denominator. Okay, so this is going to be x to the 20/12 power minus 3/12. Okay, so when I subtract this, this is going to become x to the 17/12. Okay, all right, and it says to leave your answer in exponential form. So I believe I can leave my answer like this. If you want to leave your answer in mixed number, I guess you can do that too. Yeah. And if you wanted to leave your answer in mixed number for your power, you can rewrite this guy as x to the, so 12 goes into 17 one time with 5 left over, so 1 and 5, 12. So normally you don't leave your answer in mixed numbers as far as your powers, but I mean, if you really wanted to, I guess you could, but normally you see your answers written like this for powers. Okay? All right, so moving on. Okay, so now you got a whole bunch of y's all connected, like these two y's in the bottom are connected via multiplication, and these two y's in the bottom are connected to the y in the top via division. So you're going to have a whole bunch of stuff going on. Okay, but the main thing you got to understand is these y's are on the bottom, this y is on the top, so you're going to be basically subtracting powers. Okay, so let's go for it. So you got y to the 2/3 minus 1/2 minus 3/4. Okay, so the 1/2 and the 3/4, they're minused because they're on the bottom of the fraction. So anything on that bottom of the fraction is going to be subtracting to the number on the top. Okay, and you can also think of it this way. You can ask yourself this question: How did those y's get to the bottom in the first place? Well, the y's gone to the bottom in the first place because they had negative exponents, and the negative exponents send those y's to the bottom. Okay, and that's why you see -1/2 and -3/4, because the only way those y's are going to get on the bottom is if a negative exponent sent them there. And that's why it's -1/2 and -3/4. But when they get to the bottom, the negative goes away, and it's just 1/2 and 3/4. Okay, so that's why you really got to understand the role of the negative sign for exponents, right? They tell you to bring the entire base and exponent to a different location. Okay? All right, so let's see. What are all these numbers going to match at as far as a denominator? I think they're going to match at 12 again. Okay, so since everybody has to have a 12 on the bottom, let's see. These guys are going to become, what is this going to be? 4 times 4 over 4, so that's going to be 8 over 12. And this guy, right? How do I turn this 2 into a 12? I multiply by 6, so 6 over 12. And then the last one, how do I turn a 4 into a 12? That's with a 3. So 3 over 3, that's going to be 9 over 12. Okay, so I kind of did some stuff in my head. Yeah. Hopefully you can as well. Yeah. And the only thing I did was I handled each fraction separately, right? I said to myself, how do I turn a 3 into a 12? Multiply by 4. So multiply by 4 on the top, 4 on the bottom, I get 8 over 12. How do I turn a 2 into 12? Multiply by 6. So 1 times 6, 2 times 6. So 6 over 12. Then how do I turn a 4 into a 12? Multiply by 3. So 3 times 3 is 9, 4 times 3 is 12. Okay, so I know I might have lost some of you guys, but it's good practice to do mental math as well, right? Don't just always use the calculator, but practice mental math, and that's going to get your brain stronger. Okay? All right, so let's just add all these fractions or combine all these fractions. So we basically have 8 minus 6 minus 9. So when I go 8 minus 6 minus 9, we get -7 over 12. Okay? All right, so in the instructions it says you're only allowed to have positive exponents, and right now we have a negative exponent. So this is going to turn into 1 over y to the 7/12, because that negative sign needed to go. And when I took away that negative sign, it basically said send the entire y to the 7/12 power to the bottom. Okay. So if the instructions didn't say use only positive exponents, we could just leave it as y to the -7 over 12. But it says use only positive exponents, so I had to change it into this. Okay. All right. So moving on. Okay, so we have a problem that has a lot of different x's, right? So x is on the top, x is on the bottom. Okay, so here's where it's going to get tricky. Okay, so I'm going to actually not just go straight to the single x with all the powers right next to it. Okay, I'm going to look at the bottom, and it says -3/4. So that negative is saying this message, right? So since the negative is already on the bottom, right? Notice how that x to the -3/4, he's already on the bottom of the fraction. So what he's going to say is, well, since I'm on the bottom already, my negative exponent is going to say, send me back to the top. So when this problem gets rewritten, it's going to look like this. X squared times x to the 1/3 times, oops, I'm not going to write the dot, because I didn't write it for the previous one, so just erase that dot, times x to the 3/4. So notice how your negative next to the 3/4 is gone. And the reason why it's gone is because the x to the 3/4 used to be on the bottom, but his negative told him to go back to the top. That's what a negative exponent does. It tells you to go to a totally different location, the opposite location from currently where you are. So since he was already on the bottom, I can't send him to the bottom again because he's already there. So my only option is, since he's already on the bottom, I gotta send him back to the top. Okay, so this is where kids usually, before this problem, they get into the pattern of saying to themselves, oh, negative exponent, just always put them on the bottom. And usually, for the most part, that's been correct. But we got to a brand new location of your negative exponent, and since he's already on the bottom, we send him to the top. Okay, so keep this in mind. This is a very important problem that I hope you watch. And you're not just skipping through this video by hitting fast forward, fast forward, fast forward. Otherwise, you just missed a super important concept. Okay, so all of these x's are being multiplied, so therefore all I'm going to do is I'm going to add all my powers. So x to the 2 plus 1/3 plus 3/4 power. Okay, and then I'm going to make them have all the same denominator, so I think they all have to match at a 12. So since that first number doesn't have a 12, I'm sorry, it doesn't even have a fraction, it's not even a fraction. Well, it does, it is, it's a 1 on the bottom, but yeah, it doesn't look like a fraction. So since he doesn't have anything, doesn't look like a fraction at all just yet, he's going to be multiplied by 12. Because that's how I make his bottom become 12. I got to give him a 12 on the bottom. So 12 on the top makes 24. 12 on the bottom makes 12 on the bottom. Okay. Then how do I turn a 3 into a 12? Well, I multiply by 4. So 4 over 12. And then how do I turn a 4 into a 12? Well, I multiply by 3. So that's going to turn into 9 over 12. Okay, so this is a lot of numbers. Okay, so when I add these guys all up, I get 24, 28, 37. So x to the 37 over 12 power. And there you go. Okay? All right. So one problem left, number 6. Okay, so this one says, out of the 4 forms that you see below, which one can 3x to the 3rd power, and all of that to the 4/7 power, which ones can that be written as? Okay, so let's start to think about what this is. So this basically says I got 4 3x to the 3rd powers, right? I got 4 of them. And I'm going to stick all 4 of those 3x to the 3rd powers in a 7th root radical. That's what it says to do. So I'm going to follow my instructions. There's my 7th root radical. And I'm going to put 4 3x to the 3rd powers in there. So 3x to the 3rd power once, twice, 3 times, 4 times. Okay, so do I see, okay, I'm not going to circle anything yet, so let's just put this all together. So 4 3's make 81 when I multiply them together, and 4 sets of x to the 3rd power makes x to the 12th power. So is that any one of my, actually what did I do? I wrote my radical wrong. I put a 4 in there because I was thinking about 4 3's. Okay, it's a 7 in there, sorry about that. Okay, so do I see that as any one of the options that they say as an answer? Oh yeah, this first guy is one of those answers, so I'll put a yes right there. Okay, all right, and the second answer, that looks kind of weird because that one says the 81 escaped from the radical. Does it look like I have 7 81s inside this radical right now? Is there any way this 81 is going to jump outside? There's no way. Right? For this 81 to go outside, I need 7 of them. Does it look like I have 7 81s right now? No, I don't have 7 81s. That is not going to happen. So I'm just going to put a no on this blank. Okay. Let's see. This third guy says, wow, this third guy looks exactly like what I have here, except the only difference is my answer has 81. What they're saying could be correct, and I have to figure out whether it is or not, is they put a 3 in that spot instead. So, that doesn't look right either, so I'm going to say no. And this last potential answer, wow, he has some x's on the outside. Ooh, can I put some x's on the outside? I think I can. You know why? My radical is a 7th root radical, meaning that if I want to send anybody outside, I have to have 7 of them. And I think I have more than 7 because I have 12 x's currently inside my radical. So let's rewrite this. Let's try it out. So 7th root radical. Why isn't it writing? Okay, there we go. Okay, 7th root radical. And what is that extra squiggly line that they added in there? So I'm going to leave my 81 alone because I know that's never going to get circled. And I'm going to write 12 x's. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, and let's see if I have 7 of them that matches. And yeah, I know I have 7 that matches. That's a guarantee. So there's one set of 7 x's. Do I have another set of 7 x's? No, I don't think so. So therefore, this x gets to go outside. It's still a 7th root radical. And I still got my 81 inside there. And I got 5 x's also inside there. So does that look like the answer that's on the bottom? Yeah, it is. So that's a yes also. So the two forms that 3x to the 3rd power and all of that to the 7th power can turn into the first and the last option. And it can't be the 2nd and 3rd. Okay? Alright, so this lesson was a lot shorter than the previous one, right? But it highly depends on whether you got the first part understood. If you did get the first part understood, then this second part is a little easier. I'm not saying it's easy. The problems are way harder, right? But if you understood the first part, this will make the second part a little more manageable. Okay, so you might want to go back and watch the part 1 if you're still getting stuck on a lot of things in part 2. Okay, so I will see you in class. Bye-bye.